Jai Hind students, welcome to my YouTube channel. Students, there are three C's of life. There are three C's. There are three C's of life. First C stands for choices. First C stands for choices. Second C, it stands for chances. Third C, it stands for changes. So students, I repeat, there are three C's of life: choices, chances and changes. So you must make a choice to take a chance if you want anything in your life to change. I repeat students, you must make a choice to take a chance if you want anything in your life to change, right? So please always remember these three C's of life. Anyway, let's begin with this session with new energy, right? We will discuss in this session some very interesting basic numericals based on relative motion and relative velocity. So these are the 5 questions which we will be trying to discuss during this session. Let's start with the first one. Students, just go through the question. 2 trains are given and the length of one train is 121 meter while the other train is 99 meter. They are running in opposite directions with velocity of 40 km per hour and 32 km per hour. In what time they will completely cross each other? So, it is this case. This is train T1. This is train T2. Both are moving in the opposite direction. So students, for independent bodies, if they are moving in the opposite direction, then what will be the effective speed? That is the relative velocity of one train with respect to other would be given by the addition of their individual speeds. So in this case, the effective speed of the trains would be V1 plus V2, since the bodies are moving in the opposite direction. It is the case of relative motion, as both the bodies are in motion, right? So it will be 40 plus 32, that is 72 km per hour. If you wish to convert it in meter per second, then we have to multiply it by 5 by 18. So it will be equal to 20 meter per second. Clear, students? Now, total distance to be covered. The length of one train is 121, the other train is 99. So as to cross completely, the total distance covered should be 121 plus 99. So it will be equal to 220 meters, isn't it? So we are supposed to find out the time during which the trains completely cross each other. So we are aware time is equal to total distance divided by net effective speed. So it will be equal to 11 seconds. So students, in 11 seconds, both the trains will be able to completely cross each other, right? So we are done with question number 1. Let's concentrate on question number 2 then. Question number 2 states that when the two bodies move uniformly towards each other, the distance between them diminishes by 16 meter every 10 seconds. Diminishes means decreases by 16 meter every 10 seconds. If the bodies move with velocity of same magnitude and in the same direction as before, the distance between them increases by 3 meter every 5 seconds. What is the velocity of each body? So, there are 2 cases basically. First is the two bodies moving towards each other. This is body A, this is body B. They are moving towards each other. Suppose it is V1 and it is V2. They are moving towards each other. So what will be the effective speed in this case? It will get added up, right? In this case, effective speed would be equal to V1 plus V2. That is, V1 plus V2 is equal to V effective. V effective is 16 meter every 10 seconds. 16 meter every 10 seconds. This is distance, this is time. So it is the effective speed given. when the two bodies are crossing each other. Two bodies moving uniformly are moving towards each other. So in case of opposite direction of two independent bodies, the effective speed gets added up, isn't it? So put this as equation number 1, right? So it can be considered to be 1.6. Okay, second case. In this case, this is body A and this is body B. Now it's given if the bodies move with velocity of the same magnitude and in the same direction as before, right? It will have the same magnitude as that in the previous case. But the only difference is now they're moving in the same direction. Now what will happen is, in case independent bodies move along the same direction, then the relative velocity of one body with respect to other is given by the difference in the magnitude of the speeds of the two bodies, right? So in this case, effective speed, it will be equal to V1 minus V2. This is relative velocity of A with respect to B, right? So V1 minus V2 is equal to, in this case, effective speed is given to be 3 meter every 5 seconds. 3 meter every 5 seconds. This is nothing, but it is the effective speed given when the bodies are moving in the same direction. So let's solve these two, isn't it? So if we add 1 and 2, what do you get? V1, V1, it will give us twice V1. V2 minus V2, it will get cancelled out. So it will be 1.6 plus it will be 0.6. Isn't it? 3 by 5 is 0.6. So twice V1, it will be equal to 2.2, which implies that V1, it will be equal to 1.1 meter per second. So this is the magnitude of the velocity of one body, right? What about the other body? You can substitute this value in equation 1. So in equation 1, what you get is 1.1 plus V2 is equal to 1.6. 16 by 10 is 1.6. Therefore, V2 would be equal to 1.6 minus 1.1. That is 0.5 meter per second. So the magnitude of the velocity of the two bodies must be 1.1 meter per second and 0.5 meter per second respectively. Clear, students? So we are over with question number 2 as well, right? Let's consider question number 3. It's a real, genuine question and very, very important one. Read the question, students. Read the question twice, thrice. On a 2-lane road, car A is travelling at a speed of 36 km per hour. Two cars B and C approach car A in the opposite direction with speed of 54 km per hour each. At a certain instant, when the distance AB is equal to AC, both being 1 km, B decides to overtake A before C does. So what is the minimum acceleration of car B which is required so as to avoid an accident? Right? Try to visualize this situation. It's a very, very interesting question, students. Try to visualize this situation. It's like this. This is a road. Suppose this is the road. Right? Car A is traveling with speed of, this is car A, suppose. This is car A traveling with speed of VA. Right? And two cars B and C approach car A in the opposite direction. So B and C must be approaching in the opposite direction. And B needs to overtake car A. So B must be behind car A. So this is where car B must be. So suppose its speed is VB. And B and C are in the opposite direction. It's given. Two cars B and C approach car A in the opposite direction. Like this. This is the situation. Right? All the three cars are moving. All the three cars are moving. But car B needs to overtake car A. It means that car B, car A must be in the same lane, isn't it? So this is where car C is. Since car C is traveling in the opposite direction, it must be in the other lane. Now this distance AB is equal to AC, each being equal to 1 kilometer. Okay, this distance, it is given to be 1 kilometer. When B decides to overtake car A before C does, right? This is 1 kilometer. In SI it would be 1000 meter. So this is the representation. All the three bodies are moving, A, B and C. Now the nature of the question is such that, now look, B needs to overtake car A before C crosses A, right? So what is the minimum acceleration car B must possess? So before we try attempting this, we need to convert all the given data in SI system. Now VA, let's calculate VA. It is given to be 36 km per hour. So it will be 36 divided by 5 by 18. So it will be 10 meter per second. Clear, students, in SI. Similarly, VB and VC both are same. It is equal to 54 km per hour. So it will be 54 into 5 by 18. So 18 3 54, 5 3 15 meter per second. So don't forget to first change the units in SI, right? Now look, let us calculate the effective speed of B with respect to A and C with respect to A, right? A should be the reference car. So effective speed of B with respect to A is, both are moving in the same direction. Therefore, it would be VB minus VA. Students, always remember, we have done it in the theoretical part, that whenever the two independent bodies are moving in the same direction, then the relative velocity of one body with respect to the other is always given by the difference in the magnitude of their individual speeds. So that is what I have written over here. So it is VB is 15 and VA is 10. So it will be 5 meter per second. So what is the effective speed of car B with respect to car A? It is 5 meter per second. Its speed with respect to a person on the ground at rest is 15 meter per second. But the effective speed of car B with respect to car A, which is also in motion, is only 5 meter per second. Both are moving, right? It is closing down the gap, obviously. Similarly, what is the effective speed of car C with respect to car A? They are moving in the opposite direction. So the speed will get added up. So it will be VC plus VA. So it is 15 plus 10. So it will be 25 meter per second. I hope it's pretty clear, right? Now what we do is, first we will try to calculate the time which car C will take to cross car A. Clear, students? So, time taken by car C to cross car A. So, what will be that time? What is the distance between C and A? It is 1000 meter, right? And what is the effective speed of car C with respect to car A? That is 25 meter per second. So it will be equal to 25,400 and 0. 40 seconds. So car C will tend to cross car A, in 40 seconds. Students, now try to understand or try to visualize this situation. Car B, in order to avoid any sort of accident, in maximum time of 40 seconds, this is the maximum time available to car B, he needs to overtake car A before C does. Clear? So the maximum time which the car B can take to overtake car A is 40 seconds. Right? Now consider car B. Its effective speed with respect to A is 5 meter per second. And it needs to accelerate. Right? It needs to accelerate. So it is the case of uniformly accelerated motion. So we can very much make use of second equation of motion, right? Which is S equals to ut plus half at square. What is S? What is the distance which car B needs to cover? 1000. What is U? U is the initial speed, effective speed of car B with respect to car A. It is 5. What is the time available to car B? It is 40 seconds plus half A is to be found t square. T square would be 40 square. It would be 40 square. Right? Let's solve it. So what do we get is 1000 is equal to 200 plus 40 square. It will give us 1600 divided by 2, that is 800. A. So we get 800A is equal to 1000 minus 200, it will be 800, which implies that A is equal to 1 meter per second square. And students, remember, this is the maximum time available to car B, right? So this is the minimum acceleration with which car B must accelerate so as to overtake car B before C does, so as to avoid any sort of accident. So the minimum acceleration car B required is 1 meter per second. In real life, obviously, car B needs to accelerate with a value much greater than this one, so as to avoid any sort of accident. So students, I hope you have understood this concept. It was a very, very interesting question based on relative velocity and relative motion, right? Whenever the two bodies are moving in the same direction, then the effective speed gets subtracted. When they are moving, independent bodies moving in the opposite direction, their effective speed, that is the relative velocity of one body with respect to the other, it will get added up. So that is what we have employed while solving this question. Clear, students? Okay, let's move to question number 4. Again, gem of a question. It's a very, very good one. Just try to read the question, students. Actually, I'll read the question for you. There are two towns, A and B. They are connected by a regular bus service, with a bus leaving in either direction every T minute, capital T minute. A man cycling with a speed of 20 km per hour in the direction from A to B notices that a bus goes past him every 18 minutes in the direction of his motion and every 6 minutes in the opposite direction. What is the period capital T of the bus service, and with what speed, which is assumed to be constant, do the buses ply on the road? Right? This is, students, a very, very important question. So let's try to see its solution. Okay, fourth question. Again, I must read the question. Students, the thing is, once you are able to understand the question, believe me, 40-50% question itself gets solved without doing any sort of solution, right? So first you need to understand the nature of the question, what's given, what is required of you, right? What formula is to be used. So let's refer to the question once again. Two towns A and B. This is town A, suppose. This is town B. These are the two towns, right? This is town B and this is town A. They are connected by a regular bus service with a bus leaving in either direction every T minutes. Okay, this is bus. This is also bus, plying between these two cities. Suppose its speed is V, which is to be calculated. This bus service is available after a regular interval of time, capital T minute. So after every T minute, the buses leaves the city in either direction, right? So let the speed with which the buses ply between these two towns is V, which is assumed to be constant as per the question. Now, a man cycling with a speed of 20 km per hour in the direction from A to B. This is a cyclist. This is a cyclist. He is traveling from A to B. Suppose BC, and it is given to be 20 km per hour. Its speed is 20 km per hour, and in the direction from A to B. In this direction, the cyclist is moving, and he notices that a bus goes past him every 18 minutes in the direction of his motion. So when a bus crosses him, so he notices that after every 18 minutes, the bus tends to cross him, right? When the bus is in the same direction as that of its direction of motion, right? So, case 1. When bus is moving from A to B. So what will be the effective speed of bus with respect to the cyclist? Effective speed of bus with respect to the cyclist. It will be equal to V minus 20. Here students, this is equation 1. Both are moving in the same direction, bus as well as the cyclist. I have told you numerous times, whenever the two independent bodies tend to move in the same direction, then the effective speed, that is the relative velocity of one with respect to the other, would be always given by the difference in the magnitude of the individual speeds, right? So, V effective means it is the effective speed of bus with respect to the cyclist. It is equal to velocity of bus minus velocity of the cyclist. It's okay, right? Now, it means after every 18 minutes, the interval is after 18 minutes, the cyclist tends to observe that bus crossing him after every 18 minutes. So, distance covered by bus in time t is how much? It will be V into t. Clear? T is the frequency. After every t minute, the bus leaves city A as well as city B in either direction. So in time capital T, the distance covered by the bus would be Vt. Simply, distance is equal to speed into time. Now, if you consider this effective speed, then after every 18 minutes, the cyclist tends to notice a bus goes past him, right? After every 18 minutes. So, what would be the equation like? Distance divided by this distance divided by effective speed, that is V minus 20. It will be equal to 18. So this is time, this is distance, and this is the effective speed. So students, put this as equation number 2. I hope you have understood this concept. This is the time, right? This is the distance covered, this is the effective speed of the bus with respect to the cyclist when it is moving from city A to city B. That is along the direction of motion of the bus, right? Now case 2. Case 2 is when bus is moving from B to A. Now consider this bus and this cyclist. What will be the effective speed of the bus now with respect to the cyclist? They are moving in the opposite direction. So effective speed or the relative velocity of bus with respect to the cyclist would be now V minus 20. In fact, V minus plus 20, right? So, in this case, the bus and the cyclist, they are moving in the opposite direction. So, in this case, the effective speed definitely gets added up, right? So, V is the speed with which the buses are flying. So, effective speed of the bus with respect to the cyclist when it is moving in the opposite direction as that of the motion of the cyclist, then effective speed would be given by V plus 20. Now, what would be the equation? In this case, the direction of his motion, and every 6 minutes in the direction opposite. So, the cyclist tends to observe that the bus goes past him every 6 minutes in the opposite direction. Every 6 minutes. So, the time is 6 minutes. So, distance covered by the bus during time capital T is Vt. So, distance is Vt. What is the effective speed now? In case of opposite direction, it is V plus 20. And in this case, the time interval, right? That is, the cyclist notices the bus goes past him every 6 minutes when the bus is moving in the opposite direction. So, time is 6 in case they are moving in the opposite direction. So, this is equation 4. So, once we have constructed the equation, now it's the mathematical part which we need to concentrate, and that will give us the answer. There are two variables and there are two equations available, equation 2 and equation 4, and we can easily solve it, right? So what to do is, let's divide these two. Second divided by 4, right? So let's try to solve for V as well as for T. So let us divide fourth equation from second. Let's see. So second divided by 4. What do we get is second divided by 4. VT get cancelled. So we get V plus 20 divided by V minus 20. Right? Left hand side. We are doing second divided by 4. VT get cancelled. So V plus 20 divided by V minus 20. It would be equal to 18 by 6, which will be equal to 3. Simple. We will easily get the value of V. So cross multiplying, we get V plus 20 is equal to 3V minus 60. So what we get is 20 plus 60 is equal to 3V minus V, or 2V is equal to 80, which implies that V is equal to 40, and it will be in kilometer per hour, right? It will be in kilometer per hour. So that's the answer of the first part. This is the constant speed with which the buses ply from city A to city B or from city B to city A. Clear, students? Now we have obtained the value of V. Now substitute this value of V in either of these two equations so as to get the value of capital T. Right? Let's do it. Let's substitute this value in this particular equation and we'll get the result for capital T as well. So from fourth equation, V is 40. So 40 capital T divided by 40 plus 20 is equal to 6. So 40T is equal to 6 into 60. That is 360. So capital T would be equal to 360 divided by 40. So that would be equal to 9. And remember, students, capital T, it's a minute. So T is equal to 9 minutes. So after every 9 minutes, the buses leaves city A and city B. Clear, students? So this was very, very important question. Right? Do practice this question. Try to read the question. Try to visualize the question. And then you will be easily able to solve it. Right? Using the concepts of relative motion. Okay, students, let's proceed to the last question. Question number 5. Two trains, A and B, each of length 400 meter, are moving on the two parallel tracks with uniform speed of 72 km per hour in the same direction with A ahead of B. Right? This is 400 meter. Again I repeat, two trains A and B of length 400 meter each are moving on the two parallel tracks with uniform speed of 72 km per hour in the same direction with A ahead of B. This is suppose train A. It is moving along this direction, and this is train B. Both are moving with the same speed, isn't it? So VA. Now first convert 72 km per hour into meter per second. So it will be 5 by 18 meter per second. So it will be 20 meter per second, isn't it? So its speed is 20 meter per second. Its speed is also 20 meter per second, right? So the driver of B decides to overtake A and accelerates by 1 meter per second square. If after 50 seconds the guard of B just brushes past the driver of A, what was the original distance between them? We need to find out the original distance between them. This distance is to be found. Right? This is the distance which needs to be found. So, what we do is, first and foremost, we need to find this distance. Right? This distance is to be calculated. For that, effective speed of B with respect to A is to be calculated. So effective speed of train B with respect to train A is given by which will be its initial speed of train B. It can be written as VBA. It is equal to VB minus VA, since both the independent bodies are moving in the same direction, right? So both are moving in the same direction. So what will be its effective speed? It will be 20 minus 20. So it will be equal to 0. Students, you must remember that case when the two trains are moving with the same speed and in the parallel track along the same direction. Then to a passenger sitting in one train, it will appear as if the other train is at rest. Actually, the other train is also in motion, but it is the relative velocity that becomes 0. Same is the situation here. Here, a certain constant gap is maintained. Both the trains are moving with the same speed in the same direction. So the gap between these two will remain constant till the driver B starts accelerating his train, right? So effective initial speed of body B with respect to body A is 0. Now for body B, it's given that what will be the distance, or what was the original distance, or by what distance train B is behind train A before the driver of B decides to overtake A and accelerates by 1 meter per second square and crosses completely in 50 seconds. So acceleration is given to be 1 meter per second square. So we can make use of second equation of kinematics for body B. So which is S equals to ut plus half at square. S will be the distance covered by body B, effective distance covered by body B in time t, which is 50 seconds, right? U is the initial effective speed of body B with respect to body A. Remember, they are maintaining a same constant distance. So both the bodies are moving in the same speed, so the effective speed of body B with respect to body A is 0. So U is 0, t is 50 seconds plus half, acceleration is given to be 1, t is 50. So what you get is half into 50 square, that is 2500, which will give us 1250 meters. So the train B is initially 1250 meters behind train A. Clear, students? So I hope you have understood the concepts involved in these questions, right? As I have always maintained, students, this is not the end of all the numericals. You need to practice at your own. It's not feasible for me to do all the questions for you. I can only guide you. I can only tell you the approach that should be while solving these questions, right? So that's it for this particular episode, and do join me in my next session. I'll come up with some new set of interesting numericals. Till then, bye-bye.